Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
Remember that you will be using this point-to multi-point network type in that case where you are having your topology as hub and spoke topology. Let's move back again on R1, and if you want to change its network type, then go to serial interface 1/0 once again, and say IPOSP network type is what? Point-to multi-point. So in this way you can change their timers, and this time you will see that their neighborship will not come up. In case of point-to-point and broadcast, neighborship can come up, but routes will not get exchanged. But in case of point to multi-point and broadcast, even neighborship will not come up. Even in between point to multi-point and point to point also neighborship will not come up. You know why? Because in case of point to multi-point, your timers will become like 30 and 120. Yeah. Whereas in case of point to point or broadcast, its timers, their timers will be 30 and 10 and 40, 10 and 40, right? So this time, of course, their neighborship will not come up. But you know, if you change its timers, like IPOSPF,
hello, 10, 13, 14, yeah.
And this time, see what is happening. It is showing me that it is BDR, but now this R1 will not be as BDR longer. You know why? Because its on priority will become now 0, because if you have configured network type like show IPOSPF interface serial 1/0, you configured its network type as point-to, and in that case priority will become 0 automatically. It will not be longer eligible to become an BDR now. To become BDR. So that show IPOSPF neighborship is there, routes are not there. Have you understood it now? Now do one thing, interface serial 1/0. Even you can remove all these previous commands from here. Once again it will break its neighborship. Show IPOSPF neighbor. You have to wait for the expiration of that interval, right? Or you can say one thing, clear IPOSPF process. Then after again you can move back on R2, and you will see that neighborship will not come up. See, just wait. See, that timer has reduced than 30 seconds. And if that interval has been reduced than 30 seconds, it means it is gonna to break its neighborship after. Because if it is receiving periodic hello packets, it means after 30 it should have started from 39 itself. But this time it will break neighborship after 10 seconds now, right? So it is going to break its neighborship with R1, because on R1 you are using different timers. But you do one thing, move on R2 as 1/0 itself, and then say IPOSPF network type is point-to multi-point. So IPOSPF neighbor see, and there will not be any problem related to routes as well. So I hope that you have understood that how to change how to manipulate their network types. Then after router OSPF1, say neighbor 12.1.2, still you cannot configure neighbor statically. Has proved or not? So again it has proved that in this network type as well we cannot configure our neighbor statically. Then let's do one thing on R1 itself. This time, because we want to configure our neighbor statically, so let's configure the network type as non-broadcast only, right? So interface as 1/0. IPOSPF network type is what? Point-to multi-point. Sorry, simply non-broadcast. And then after I'll go for point-to multi-point non-broadcast, right? So this time I have configured non-broadcast. Then you do one thing, move on R2, serial 1/0 IPOSPF network is what? Non-broadcast. And this time let me capture this link as well. I will show you that all packets of OSPF will be unicasted now. I mean, they are not sending hello packets to each other automatically, dynamically, because they cannot form dynamic neighborship now. In case of network type non, okay, I think I have already configured it. Yes, that I think that command was already configured here. Do show run type section router. Sorry. I think I configured that command here. No.
Sorry, non-broadcast में भी dynamic discovery होती है.
Not non-broadcast. Let me show you. In non-broadcast, your neighbor cannot be discovered dynamically. You have to define your neighbor statically in this way. See, router OSPF1 neighbor 12.1.2. That's it. Just you are required to configure this command only on one end. Then after you will see that your neighborship will come up automatically. Let me show you. Show IP OSPF neighbor. It is still in two-way state. Of course. In case of non-broadcast, again DRPDR election will be there.
Yeah.
You have everything in your written. I taught you everything, all these things before. I have already taught you all these things before. Just go through those documents.
Only in broadcast and non-broadcast will have DRP.
So this time, just wait for a moment. It has to do. I mean, we have to do wait for the expiration of wait interval. After the expiration of wait interval, DRPDR election will be completed, and now you see that neighborship is just about to come up. But remember, if you do not configure your neighbor statically, then your neighborship will not come up. So run pipe section router OSPF, as you can see here. Right? So it is also not mandatory to configure this neighbor command on both sides, but it is mandatory to use the same network type on both ends. So I hope that you have understood that why do we require to configure this network type as non-broadcast. So wherever you will require to configure your neighbor statically, wherever you will require to send unicast updates, unicast OSPF updates, and along with DR and BDR, then you have to use your network type as non-broadcast. And if you just want to configure your neighbor statically, but you do not want to let your routers to elect DR and BDR, then you can use your network type as point to multipoint non-broadcast, right? So let me configure that now. So interface S1 by 0, say IP OSPF network type is point to multipoint non-broadcast. In same manner, I will move on R2 on its S1 by 0. I will say IP OSPF network type is point to multipoint non-broadcast, and then after I will show you that neighborship will come up. Show IP OSPF neighborship is there. It must have all routes as well. Or you do one thing, say clear IP OSPF process once, and then after say show IP route. It's not it. So this time there will not be any DR and BDR election, but still you will require to configure your neighbor statically. As you can see that we have already configured this command here. We already configured this command here that neighbor is 12.1.2, right? So remember that neighborship will not come up until you configure, unless you don't configure neighbor command.
So even if we connect with fast Ethernet link, this is the same process.
Of course. That's why that's what I mean. I want to make you understand that it is not always necessary that you can use network type broadcast only on Ethernet connections. Wherever you want, you can enable it, but as per requirement. Even in live networks, in production networks, you will see that if you are having only two routers connected with the Ethernet segment, then you will always prefer to use point to point only in place of using in place of using broadcast or any other thing. So I hope that now all these things are okay for you. Is it? Network type is done now. That how can you configure neighbor statically? And now you can also do one thing, however it is not possible here, like router OSPF1, and then you can say neighbor 12.1.2 and then cost. Okay, for this neighbor I have defined its cost as 50 now, and now you see show IP route to reach R2's lane network, which is 20's network. Where is that?
Equal to 1.1.2/32.
See 51. So this time it will not add the cost which is configured on its own interface. Let me show you. Show IP OSPF interface serial 1/0. What is the cost of this interface? And however it is receiving updates on this interface from this neighbor. Hello. So it should have considered the cost of this interface only. Are you getting my point or not? So in case if you have configured your neighbor statically, then also you can change the cost per neighbor basis. You know why this option is there? Because might be possible that on a single interface you are having multiple neighbors, but you want to modify the cost only for a specific neighbor, not for all neighbors. Because if you change the cost of the interface, then it will be effective for all neighbors. Let me show you. Let me prove all these things. Let's say, guys, this is R1, this is switch now, this is R2, this is R3, this is kind of multi-access network. And now you have configured this R1 as a DR because it is working as a hub. These all are spokes. Now the thing is, R1 will be having neighborship with R2, R3 as well as R4. Now R1 is receiving same prefixes coming from R2, R3 and R4, but it wanna preferred via R2. So you are required to change your cost to achieve this task. Now you are having an option to change this cost on R1's this interface, right? FA0/0. But if you change the cost on this interface, then it will be applicable for all those neighbors. For all these neighbors, R2 as well as R3 as well as R4. But if you wanted to change it only for R3 and R4, then you have to change your cost per neighbor basis. But this command cannot be configured if your network type is broadcast. This command can be configured in that situation only where you have configured your neighbor statically. If you have not configured your neighbor statically, then also you cannot use this command to modify your cost per neighbor basis. That's why I said here that if you check the interface of R1 like show IP OSPF interface serial 1/0, you can see that its default cost is what? 64. But here show IP route 20.1.0, 20.1.1 because loopback is there, right? So what is the cost to reach it? 51, because cost 1 is there for loopback interface itself. As you can move on R2, you can see show IP OSPF interface loopback 1. So by default cost is what? 4. And then it is adding its own cost as 50. So total cost have become now 51. Have you understood it or not? So in this way you can also modify your cost per neighbor basis as well. Now I have taught you all these things. After it, let's start to modify your timers as well. That how can we modify timers? We have already gone through all network types and all these basic things, right? That how do they perform DR election, how can we manipulate it, right, by modifying its priority and all these things. But remember, in OSPF, once your DR has selected, it will always remain as DR. There is no preemption available for DR election. It is not like that, let's say BDR have become now DR and now DR have came up once again. So it does not mean that once again that old router would become DR in your network. No, because there is no preemption available in OSPF. Once a router have become DR, it will always remain as DR until it goes down.
आपने ये दिया अभी का वो करवाया तो उसमें करेक्शन है जो हम उस दिन देख रहे थे ना एक्सटर्नल रूट की जो मैट्रिक्स 0 आ रही थी वो सिर्फ इस वजह से आ रही थी क्योंकि वो लूप बैक था और आरआईपी से रीडिस्ट्रीब्यूशन हो रहा था। अगर हम किसी और से करवाते हैं आगे का राउटर हो जो, तो उसकी मैट्रिक आती है हमेशा जीरो नहीं रहती।
ओके 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 ओके
जो मैट्रिक आरआईपी की होगी
ओके 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 ओके
वही आती है।
ओके ओके ओके
देखा था मैंने।
but in case of ESGRP I think it will not work in that way.
नहीं ये आरपी का बताओ।
ESGRP मैट्रिक लेकर के आ रहा था वो वाली पुराने वाली।
उस दिन हम जीरो देख लेते हैं ना एक्सटर्नल डाटा के नीचे उस रूट के लिए।
Have you guys understood it? He said that in ESGRP, but you should have this. So I hope that now you have understood all these things, that how can you perform all these type of practicals, right? After going through all these things, let's go for that how to modify your timers. As you know very well, hello interval and dead interval. And if timers do not match, your neighborship will go down. Is it necessary for me to go for
No.
configuring timers in OSPF now? I have already configured both commands, hello interval as well as
Dead interval.
dead interval. And you must understand the uses of hello interval as well as dead interval, right? Then after it, let's do one thing. Let's talk about that how can we modify the cost of the interfaces as well. Like show IP OSPF interface serial 1 by 0. If you want to modify the cost of this interface, you can modify its cost by using this command IP OSPF cost, and then you can configure whatever you want. However, that cost was calculated with the help of formula, but this time if you configure any cost, then it will manipulate that automatically calculated cost, right? Like here, if you have configured it as 100, then it will always show you show IP OSPF interface serial 1 by 0. It will show you that its cost is now 100. So in this way you can modify the cost of link, cost of the interface, just to manipulate your path selection, right? Then interface S1 by 0, just remove this command. Apart from it, you can also change your cost calculation formula. As I said, that if you are having any link which is having bandwidth more than 100 Mbps, then the cost will remain same for all type of links, for all links, whether it is 1 gig, 10 gig or 40 gig or more than that. So now to change that, actually you can see that by default its formula is what? So IP protocol, you can see here that by default its reference bandwidth is what? 100 Mbps. So IP OSPF interface serial 1 by 0, by default its cost is 64 because bandwidth of serial interface is 1.544.
Yeah.
So if you divide your 100 by 1.544, then it will become 64. It will become 64. Now the thing is, if you wanna modify your reference bandwidth, remember that your reference bandwidth should be equal to that bandwidth which is the highest one in your network, which is highest one. Let's say that you are having highest bandwidth available in your network as 10 gig or 20 gig. So if you are having highest bandwidth as 20 gig or 40 gig, then you have to configure your reference bandwidth as 40 gig. So it will be depending on the available highest bandwidth. So router OSPF 1, and then you can say auto cost reference bandwidth, and then you can make it like I have made it 100,000, which is
1
because it is in case of it is in form of Mbps actually.
Yeah, 100 Mbps.
So if I'm saying only 100, it means 100 Mbps. If I'm saying 1000 Mbps, if I'm saying 10,000, 10 gig.
10 Mbps.
If I'm saying 40 gig, then I have to say 40,000. Show IP protocol. So let me show you now. It will become 40,000 Mbps. So for the link of 40 gig, for the link of 40 gig, the default cost will be 1. But if there is any other link which is having bandwidth of 10 gig or 20 gig, the cost will be different. Hello.
Yeah.
By using this command auto cost reference bandwidth, you are changing the default cost calculation formula of OSPF, because this formula will get failed wherever or whenever you will start to have links of bandwidth higher than 100 Mbps. So in this way you can change it. Then after, you can see show IP OSPF interface serial 1 by 0, and you will see that the cost is now 25906. If you check the cost of show IP OSPF interface, See, its bandwidth is 10 Mbps. That is why cost is now 4,000. Because you will divide 40,000 by 10. You will divide 40,000 by 10. That is why it have become now 4,000. Reference bandwidth. So I hope that you people have understood it now. That how can you modify your cost of the interfaces by modifying your reference bandwidth? How can you modify the cost of your interface by configuring cost itself onto interface? How can you modify your cost per neighbor basis as well? But per the neighbor command is yeah, of course, like if you are not configuring your neighbor statically, then you cannot configure that command, that neighbor, and this is cost for this neighbor, right? So make sure that, I mean, there are some limitations for neighbor command actually. So you must remember all those limitations. Then after it, because we have performed all these things here, next is going to be that how to configure authentication in OSPF. As you know very well that OSPF supports 3 types of authentication. Are you getting my point or not? It supports 3 types of authentication now, which is by default plain text type 1 and MD5, which is type 2. So now let's go and configure this authentication here on R1. It is very simple. Interface S1 by 0. If you want to configure plain text authentication, the very first command will be IP OSPF authentication and enter. To enable this command is used to enable type 1 authentication onto this interface of this router, right? Then after it, next command will be IP OSPF authentication key Cisco. Show IP OSPF neighbor. See, it is sending hello packets from 12.1.1, and you will see that it will be having now authentication field over there. Inside the OSPF header itself, simple password and your password. Next hello packet, even you can also find your password as well. Right? So this is the plain text actually. So this time you can see that it has to break its neighborship now. Now let me do one thing. Let me configure its network type as IP OSPF network type is what, point to point. In same manner, I'll move on R2. I'll make it now. So it must form. I mean, it is not going to form neighborship because due to mismatch of authentication or authentication mismatch. You can say debug IP OSPF adjacency, not adjacency, actually you have to say events. Debug IP OSPF events will show you that okay, why OSPF neighborship is not coming up, right? So this time you can see that mismatch authentication type input packet is specified 0, whereas we are using type 1. So now you have to move on R2 and you have to configure same authentication type and authentication key on R2 as well. So move on R2 S1 by 0, IP OSPF authentication key is what? Even now neighborship will not come up. However, key is matching, but still on R2 you have not enabled type 1. To enable type 1 authentication, this command is really important. It's mandatory. Now you will see neighborship will come up. So sometime you will see that key will match on both ends. Key will match on both ends, and you will simply look at only key. You will not look at that command, that whether this type of authentication is enabled or not enabled. So NT shoot actually might be key will be same and will be configured on both ends, but type will not be enabled on any one side and will mismatch, and also neighborship will not come up. Have you understood it or not? So this time you are using plain text, and let's move again back on R1 and let's say we want to configure MD5 authentication. So command will be IP OSPF authentication is what? This time I wanted to use message digest. So message digest will get enabled, and then IP OSPF message digest key MD key 1, I have taken key 1, and you can take any key in between 1, 2, 2, 5, 5. I have taken 1 MD5, and then your password is, let's say, Cisco 123. Once again, it should break neighborship, and you will see that it will break neighborship after 6 seconds. After 2 seconds, it will generate log message. Now it has broken its neighborship, right? Debug IP OSPF events. Once again, it will show you that it has broken neighborship due to mismatch of authentication type. So we are using type 2, whereas input is specified with type 1. So you do one thing now, go to R2, now say IP OSPF authentication message digest 1 MD5, sorry, IP OSPF message digest key 1 MD5 and Cisco at will not come up because still type is not enabled. I'm just doing wait, so neighborship is not coming up. So because neighborship is not coming up, I have configured now this IP OSPF authentication message digest command as well, and now you will see that neighborship have came up. Let's move back again on our one. See, and this time hello packets are containing your data, and this is your data, this is your password. Key ID is still there, right? Is not it? Now in iOS 15.3 or in iOS XE, you are also having one another type of authentication which is known as cryptographic authentication. Cryptographic authentication. There is no type for them. You are having type field only for null. I mean these three types of authentication, you are having your type like type 0, 1 and 2. But for all those type of authentication, you do not have any type field, right? Any type specification. So now they have launched one new type of authentication which is known as cryptographic authentication, in which you can configure keychain. Means that in OSPF now, in iOS XE or in iOS 15.3, you can use keychain to configure authentication in OSPF as well. And the commands will be something like this: keychain test key 1. Then you can also configure send lifetime, accept lifetime, same as ESGRP. They have included this option, this feature in OSPF for rotational keys. Previously, it was not possible to configure authentication in OSPF with using keychain, but now in new iOS or in iOS XE, it is possible to configure keychain in OSPF as well. After configuring key 1, you will say key string, which will, let's say, Cisco at Cisco exclamation 1 2 3 4 5 or whatever it is, right? Then after you have to say cryptographic authentication. Cryptographic, this command is not supported by this router. Even I'm also having iOS 15.2, but it is not supported by 15.2 as well. So you will say cryptographic, and then you will press question mark. It will show you, it will list it all cryptographic mechanism, all cryptographic types, you can say. Like over there you will find SHA, MD5, HMAC SHA with bit 252, then 128 as well, 64 bit is also there. So it will be depending on you that what you select over there. But remember that on both sides this cryptographic type must be same. This cryptographic mode must be same. If you are using here SHA HMAC 256, On another end also you have to use choice MAC 256. Are you getting my point or not?
Yes.
So in this way you can define your cryptographic mode, and then after go to simply your physical interface like serial 1 by 0 and then say IP OSPF authentication, and then over there you will find this keychain option, and then your keychain name is what? That's the only thing that you will require to do. You will require to configure in OSPF during cryptographic authentication. Understood? So in this way you can configure cryptographic authentication in OSPF.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.